Hello, I am Devayan Ghosh and I will be presenting my code for assignment 2. First, I imported all the modules, then I connected my Google Drive so that I can use the downloaded data. Question 1 was about predicting wine quality for red and white wine. First, I have loaded the data, then I visualized it, and then I splitted the entire dataset into training, validation, and test sets. Then I moved to the pre-processing part. There were no null entries in any of the columns for either of the datasets. Uh, Histograms of all the columns were well spread. Therefore, we won't be dropping any feature as of now. In this part, I have written all the statistics for each of the columns so that I can use it in the fourth part for the Streamlit app. We have transformed all the data, all the columns to zero mean and unit variance. I have plotted the correlation matrix for red as well as white wine. Here we can see that none of the columns are correlated to each other by an absolute value of zero point 0.9 or more. Therefore, we won't be dropping any of the features. Now we move to training the models. As this is a regression problem, we will be using regressor for training the model. We'll be doing hyperparameter tuning using for loops, and then we'll select the best model on the basis of accuracy score and F1 score. Here I am using accuracy and F1 score as a matrix for deciding the best model because the target variables of this dataset don't have continuous values, but they are discrete integers. The predicted levels of regressor are rounded off and compared with the integer target values to find accuracy. For random forest model, I have used the number of trees and maximum depth as the hyperparameters. Accuracy of random forest model for red wine comes to be 62.5%, and for white wine is around 70%. For SVR model, I have used the regularization coefficient and gamma as the hyperparameters. Accuracy for SVR model for white wine is 66.25% and for white wine is around 67%. For neural network, I've used the number of nodes in the hidden layer and activation function as the two hyperparameters. Uh, Accuracy of the neural network model for red wine is 57.5% and for white wine is around 57%. Also, it is to be noted that I am saving the best models as .pkl files so that I can load them for demonstration in the part 4 in the Streamlit app. Determining the feature importance for random forest model is straightforward as the random forest model already has an inbuilt feature called feature importances. For the SVR model and neural network model, it's a bit complicated. We'll be using an indirect method of permutation importance. In this method, some subsets of the features are randomly chosen and the decrease in accuracy is noted. The feature for which the maximum decrease in accuracy takes place is marked as the most important feature and so on. Now we'll test the red wine data on white model and vice versa. As expected, all the models are giving mediocre accuracy level of around 40 to 50%. Question 2 is a classification problem. First, I have loaded the data and visualized it. Then I splitted the data into training, validation, and test sets. For the pre-processing part, we'll first start with the null entries. We can see that most of the columns have some null entries. So to remove them, we'll use multivariate feature extraction, sorry, multivariate feature imputation. Uh, in multivariate feature imputation, the columns with null entries are predicted using the other features. After doing the imputation, we can see that there are no more null entries in any of the columns. Histograms of all the variables are well spread, and so we won't be dropping any feature based on their histograms. Now we'll scale all the columns to zero mean and unit variance. The correlation matrix is as follows, and we can see that some of the correlations are having an absolute value of higher than zero point 0.9. So we will be dropping one of each pairs to remove any correlation in the data features. Training portion is pretty similar to the first part. The only difference is we'll be using classifiers instead of regressors everywhere. Apart from that, the hyperparameters are almost mostly the same as in the first part. So after the training is done, we can see that accuracy of random forest model is around 97%. For support vector model, it's 99.38%, and for the neural network model, it's around 99%. Uh, Now we'll try to do recursive feature elimination to see if the performance gets better. So as we know, the random forest directly uses feature importances. So we'll be using the random forest model for feature elimination process. Once the best important features are selected, we'll be transforming the training and test data to those features and do the predictions. So after doing RFECV, we can see that accuracy of random forest model is 96.3%, and for SVC and neural network models, it's 98.15%. So we can infer that in this case, the accuracy of all three models has slightly decreased. However, this might not be the case for other classification problems where the accuracies were initially not this high. Question 3 is about using a pre-trained CNN model to extract features and do classification. First, some data transforms are done. Also, the data sets are separated as training and validation sets in different folders. This particular function is to display some of the sample images. Now we'll move to training. This function takes care of both the training as well as the validation. And visualize model, this function is for displaying some of the images along with their predicted labels. Here they are extracting the features out of pre-trained ResNet 18 models. So after the model is trained, we can visualize the model by plotting some of the sample images along with the predicted labels. This function returns features and labels from the given data evaluated on a pre-trained model. In this part, we'll do a classification of males and females. The used dataset is attached in the submitted zip file. We'll use the extracted features of a pre-trained ResNet 18 model as input to our SVM and random forest models. As expected, the shape of training data comes to be number of training samples into 512. Then we use grid search to get the best model. Accuracy of SVC model comes to be 82.5%, and F1 score is 0.811%. For the random forest model, its accuracy is 80% and F1 score is 0.795. So we can see that the performance of SVC model is slightly better than random forest in this case. Question 4 is about deploying the Streamlit app to a browser. This activity cannot be done directly on Collab, so I have deployed it on my local host. The code used for making the app is attached in this notebook. Basically, we'll be getting input from the user through the sliders, test it on our trained model, and finally display the predicted label. I've done this on VS Code, so on running this command, a new web browser will be opened. So I have done this and set the sliders to some of the values as per our test cases. First, we'll start with test cases from the red wine. For example, if we check about this test case, the random forest model for red wine gives predicted wine quality of 5, which is the correct label. Now we'll test the same with SVM model, which also gives a predicted quality of 5. Neural network also gives correct label. Now we'll move to our second example. The random forest model gives an incorrect label of 7. Support vector model gives incorrect label of 7, and neural network model gives an even inaccurate label 6. Now we'll move to the white wine test cases. For this test case, the random forest model gives correct label. Support vector model also gives correct label, and neural network model gives inaccurate label of 6. Now moving to the second example of white wine. Random forest model gives inaccurate label of 5. Support vector machine gives an even inaccurate label of 6, and neural network model gives the correct label 4. So in general, we can conclude that as the data is imbalanced, uh, the models tend to give 5, 6, 7 values more frequently, and the other target values are mostly not predicted accurately enough. As we can see in case of the class 4 in white wine and class 8 in red wine. This concludes my presentation. Thank you.